Hey everyone, glad to see you again. Happy New Year. Hope you had a great holiday. I thought I'd take a little time to talk about what we are doing in math class, and that is fun with fractions. Today we reviewed two things, and we also learned a little bit more about equivalent fractions, as well as how to compare fractions when you see fractions with different numerators and denominators. So let's get right to it. The first thing that we talked about today in fractions is parts of a whole. Remember, a fraction can be a part of a whole. So if I have my pizza and I divide that into 8 pieces, and I see that my friend Sophie has eaten 2 of those 8 pieces, we would express that as a fraction of 2/8 pizza eaten. Okay? So a question then would be, how much of the pizza remained uneaten? Or how much pizza was not eaten? Okay? So we would count those parts, and we would see that I've got 1, 2, 3, 4, 5, 6 pieces that weren't eaten out of the 8 total. So 6/8 were not eaten. Alright? So that's what we call part of a whole. So it's the fractional part of the whole entire object, whether it be a pizza or a pie or anything like that. The other fractional things that we talked about were what we call parts of a set. Now, parts of a set is when we have pieces like this. Maybe we have that many pieces, but we're going to join these together as a set. Maybe it's like boxes of Oreos. I've got 3 boxes of Oreos, and each box has 4 Oreos. These are super double stuff, fudge covered Oreos. That's why there's only 4 in a box. And this time, I ate all of these Oreos. Okay? So when I look at the sets now, I'm going to make a fraction based on the sets, not the individual pieces of the sets. So I've got 3 sets total, and I ate 1 set. Okay, so I ate 1/3 Oreos eaten. Okay, so then how many Oreos weren't eaten? Well, that's the remainder. Okay, so 2/3 not eaten. Okay, so that's our review of fractions. Part of a whole, part of a set. The next thing we did today is we looked at equivalent fractions. Equivalent fractions, remember, are fractions that are the same size but have different names. So, let's say, for example, I have my piece of pizza, and on this piece of pizza, I'm going to divide it into 2 pieces. And on this piece of pizza, I'm going to divide it into 4 pieces. Let's say I ate one of those 2 pieces of pizza. Well, we just talked about that fraction would then be 1/2. Now, let's say I ate 2 of these 4 pieces of pizza. Well, then that would be eating 2 out of 4 pieces. But now when I look here, I see that these 2 things are exactly the same. So we could say that 1/2 is equal to 2/4. Alright? Now we can also make equivalent fractions by multiplying by 1, because we know that the property of 1 tells us that anything multiplied by 1 is itself. But what we're going to see here is that with fractions, when we multiply by 1, we get a different looking fraction, but it actually means the same thing. So for example, let's take that 1/2 and let's multiply it by 1. Now you notice I'm going to make my 1 into a big box like that. So what happens if I multiply, instead of calling it 1, I'm going to call it 2/2. Because we know that any number over itself, like 3/3, is equal to 1. It might be 101 over 101, and that is still equal to 1. So no matter what I multiply by 1, I get the same number. So I'm going to take 1/2 and multiply it by 1, but I'm going to call that 1 2 over 2, or 2 seconds. And when I multiply fractions, I multiply across. So 1 times 2 is 2, and 2 times 2 is 4. Look at that. That's the same fraction I have right there, 2/4. Okay? What if I took that 1/2 and I multiplied it by 5 over 5? Again, I'm going to put a big box because that box tells me that's 1. I multiply across. 1 times 5 is 5. 2 times 5 is 10. So that's how we get equivalent fractions. Now, what if I found out this? What if I had 6 twelfths, and I wanted to find out how many halves that is? Well, that's now a division problem, because I'm going from a bigger number to a smaller number. So instead of multiplying by 1, guess what? I'm going to divide by 1, because in division, any number divided by itself is the same number. So let's work backwards. 12 divided by what is 2? Well, I'm going to put my 1 right here. And just so you see in a different color, I know that 12 divided by 6 is 2. 6 over 6 is 1. So 6 divided by 6 is now 1. Look at that. 1/2 is also equal to 6/12. Okay, so that's equivalent fractions. The last thing that we talked about today is comparing and ordering fractions. So up here at the top, I've got a candy bar, and it's divided, I don't know if you can see that, into 3 pieces. And down here I've got a candy bar, and it's divided into 6 pieces. So let's say I ate 2 of these pieces. It's kind of like the example I gave you at the beginning. Alright, so I will have eaten 2/3 of my candy bar. Remember, when we're talking about fractions, we're always talking about the shaded parts. And now down here, I only ate 2 of those 6 pieces. So that would be 2/6. So, looking at that picture, which fraction is bigger than the other? Well, obviously the top one. And if it's a candy bar, I would much rather have eaten 2/3 rather than 2/6. So I can write this as a number sentence. 2/3 is greater than, remember my mouth is going to open toward the bigger number, then greater than 2/6. Okay? So that's what we call comparing fractions. Alright? Now what if I had one more candy bar, and I'm going to call this, I'm going to divide it into 8 pieces. And I'm only going to eat 1/8. Well, obviously 1/8 is the smallest piece. 1/8. So now, if I were to ask you to put these fractions in order, you would do it like this. And then you have to make sure that you read your directions, because sometimes they might ask you to put fractions in order from smallest to greatest, or from greatest to smallest. So for this example, let's put them in order from smallest to biggest. So which one is the smallest fraction? Well, 1/8 is. Which one's the medium fraction, or the one in the middle? Well, 2/6 is. And which one is the biggest fraction? Well, that would be 2/3. So now I've taken my fractions and I've put them in order from smallest to biggest. And I still contend that I would much rather have 2/3 of a candy bar than 1/8 of a candy bar. Alright, so that's our fraction review. We're going to be working more with fractions, and we're going to be talking about fractions with decimals and mixed numbers, which is a whole number with a fraction. Alright, so I'll see you next time.
That